stuff on, but I just use it to watch Netflix.
Whoa!
Parametric
Parametric what?
It's freaking out. That tells me there's probably an update that I need to run on my iPad.
like
When it started doing that last year, it was like there was an update that I needed to do.
Actually, I might need to check for that too.
Like, it's supposed to automatically do it, but
When I don't have enough storage.
our Wi-Fi's been going out at night for some reason. Like, they've been doing, like, maintenance or something. So I think that it's just not running because our Wi-Fi's been down every day at, like, 2 a.m., which is when it's been down from, like, midnight to 5 a.m. every day, I think. Because I get a notification because, like, our front door has, like, a keypad on it, and it's connected to Wi-Fi, so, like, I get notifications when the door's, like, opened and closed and stuff. And
That's like when emails need it.
yeah.
Really?
So it, like, it was like, it has lost connection. Like, our Wi-Fi's been in and out, like, for a while. Like, every day. It's been annoying, but it's fine. Okay. So, gonna be honest, there's not a ton that we need out of this section. Not 100% sure why it's in there. There's really not anything as far as the AP exam with this stuff, so I'm only gonna do a very few examples from this, like, one little pool of problems, essentially. As far as that goes, and that's gonna be it. So, pretty short and sweet. So they say a parameterization is given for a curve. The first thing says to graph the curve, which we're not actually going to do. We'll kind of maybe briefly talk about it on a few of them that are ones that we would know, but otherwise, like, you don't need to worry about that part. It wants to know the initial and terminal points, if any, because some of them they'll have, like, 0 is less than or equal to t is less than or equal to 10 or something like that, so you could have something like that. But then the part that we're really doing, which is the more important part, is to find a Cartesian equation for a curve that contains a parameterized curve. What portion of the graph of the Cartesian equation is traced by the parameterized curve? So number 6, they give us x is equal to negative root t, y equals t, and t is greater than or equal to 0. What is happening? Thing like literally having a mind of its own right now.
I have a question
I
about iPad.
may have an answer.
So, when it like starts to time out, I guess, and the screen goes dark, does it also go dark in the video?
No, I asked somebody that one time when it happened in class, somebody that had to watch it later. I was like, can you tell me if it does? And they said it doesn't.
I didn't even think about that. Yeah.
But if it goes out while it's screen recording, you lose the screen recording.
It doesn't even save it.
So you have to hit, like, the end on the screen recorder. It doesn't. Yeah, I've wondered that before. And so I asked.
I remember when I learned you could put the mic on the screen record. That was, like, my happiest day ever. I was like, how are people doing this? And I figured out, I was like,
I know, I had to look it up for a while because I couldn't figure out how to do it.
I was like, how are they doing this?
All right, so for this one, we need to get t by itself in both equations. So obviously the y equals t, t is already by itself. But how would I get t by itself in the other one?
So, we divide by negative 1, and we square things.
Yes, so it'll be negative x squared equals t. So that's just x squared equals t. And we already have that y equals t. So if I need things in terms of x and y, and I have y equals t and x squared equals t, any ideas what I can do?
What? Wait, I was trying to think about what you... Wait, can you say it one more time?
Yeah, so if I know that y is equal to t and x squared is equal to t, and I want an equation that only involves x and y because I want a Cartesian equation, what might I need to do?
So, T for Y.
Other way.
So, Well, like, it would be
Eliminate
x
the
squared equals
t's.
y.
Yes.
Okay, that's what I was trying to say.
Yeah, that's why I was like other way. I figured that's what you meant, but.
It just didn't come out right.
So I would get x squared is equal to y, and it wants us specifically to. Oh, we can leave it that way. Oh, I'll show you the difference depending on how we do it. So if y equals x squared, then what portion of the graph of the Cartesian equation is traced by the parametrized curve?
Quadrants 1 and 2. Okay, I wasn't sure what kind of answer you were looking for, so I just guessed.
So, like, where is this graph?
That's like in quadrant 3. No, that's not. It's in a something.
Oh, it's like in 2 and, I mean 3
Just
and 4.
2?
Wait, 3 and 4?
It would be, like, down like this, right?
Oh,
Oh.
before.
But
Oh, because it's x equals.
now I'm confused because my paper and the book say two different things. Hold on. Now I need to graph this because I think I said it backwards.
I need to charge my copy.
1 second. Negative root x. Zoom 6. Okay, no, it is there. I know, because I think it should be on the right, but the book says it's a left. That's why it's confusing, because that is actually occurring on the right-hand side. Like a negative square root is on the right-hand side. Right.
How does a regular square graph look again?
Like,
So it would just flip it.
yeah, so it flips it upside down. Well, the book says that one says to be on the left, but you don't really have to worry about this part, to be honest. I'm more worried about you being able to set up the equation.
Okay.
So it's on the right from, I think the book has a typo on that question. Now, if we rewrote this as x equals the negative square root of y, oh, because t is greater than 0. So thus it has to be on the right side. The left side doesn't make sense. So the book definitely has a typo on that one.
So it has to be, okay.
So we're just answering left or right on these? Or is up and
Or
down?
it can be all values then.
Cool.
Because if it's this one, if you write it this way instead, it's all values.
Can you, wait, so why is it different the way you write it? Like,
It just depends on if you solve for x or if you solve for y. Because like in the top one, it would be the right side of the equation, but in the bottom one, in terms of y, that's going to be something that's top or bottom, but it happens to take on all of them. But yeah, I wouldn't be as worried about that part of the question. Just be able to set up the equation. They're not going to be asking you for sure on the exam where it occurs. So just, yeah, I wouldn't even worry about attempting that part, to be honest.
okay.
Sometimes I do it and sometimes I don't because it just, yeah. Okay. Let's see if we can get one that makes it a little easier. 10x equals the sine of 2 pi t. Y equals the cosine of 2 pi t. 0 is less than or equal to t is less than or equal to 1. Now, do you notice anything about these ones?
They have the 2 pi.
They do, but in terms of your notes that you have, do you notice anything different with this one?
I don't know, there's the one with like the square things.
It's a
It's a what?
It's a circle thing.
It's a circle.
I like circles.
So that means, based on the information I have, that I know then that this is going to be x squared plus y squared. The y disappeared.
It's just
Equals sine squared of 2 pi t plus cosine squared of 2 pi t.
Is that just like a formula for the circle?
Yeah. It's like the very first line of the notes. And we just, instead of having an A in front, we just have a 1, so we don't have to do. Basically, if you looked at your notes, we're essentially just following that one down in terms of the steps of how we do it. So then I don't have anything in front, and we know that sine squared plus cosine squared is 1, and they have the same thing inside, so we don't really have to worry about that. So this is just going to be equal to 1. So x squared plus y squared equals 1. And in terms of the values that it would take on, it would be all of them because it's a circle. But again, I would not worry about that part. I will not ask you to do that part on a quiz or a test.
Okay.
You just need to be able to rewrite the equations parametrically.
And if the sine or cosine had something different inside, would we still be able to make it 1 or no?
If they're different, no, because they would be different things, yeah. All right, the next one, 14. We got x is equal to 4 sine t. Y equals 5 cosine t. 0 less than or equal to t less than or equal to 2 pi. Any ideas what this one is?
ellipse.
Why?
Well, because the A thing isn't the same, so like, well, one of them's A and then I guess the other's B.
Yep. So we're going to have, from that ellipse formula that you have in your notes, we would end up with sine, nope, I lied, x over the A value, which is 4, that whole thing squared, plus y over 5 squared equals 1. And an ellipse is also going to take on all values. Let's see. Flip my page. Okay, number 16. X equals 1 minus t. Y equals 1 plus t. And we have negative infinity, less than t, less than infinity.
So like T is basically like almost anything, or does that mean that it could be anything?
T can be any value then.
Okay.
So in one of these, I need to get t by itself so that I can plug it into the other one. It really doesn't matter which one, so which one do you want to do it for?
Y, I guess.
So y minus 1 equals t. Then I can take that and plug it in to the other equation. So x equals 1 minus, and then in parentheses 1 minus 1. And remember, we want to do that because it's minus, so we don't want to lose the distribution, but the distributive property of that negative sign there. So x equals 1 minus y plus 1. And so x equals 2 minus y, or we could say that y, or negative y equals x minus 2, so y equals negative x plus 2. And that's a line, so that would also take on all values there. I'm more just giving you that part, but like I said, you don't need to worry about that.
So would you want us to write out the step where you have the negative y equals x minus 2?
You don't have to.
Okay.
I just did it to make sure I had my signs right.
I mean, I just would have switched the x and the y because, you know, it's basically the same thing.
So in all these, are we trying to get y by itself, or?
Typically, yeah, because that's how we would normally think about things. It makes it easier, but
For like some of them, for like the ellipse one, we left with like the x squared plus y squared equals 1.
right, because that would have been in standard form for an ellipse.
Okay.
So. One more, 20. X equals t squared, y equals square root of 4 minus t squared. And 0 is less than or equal to t less than or equal to 2.
I think I'm pretty contented just staring at it.
So I need to get t by itself in one of them.
So let's do
Square root
x.
of x equals t.
Yep.
I was gonna do that one, but then I was thinking about plugging it in, and I was like,
And really, if we did plus or minus, when you plug it in, since it's going to get squared over here, it doesn't really matter. So you don't have to worry about that part, obviously. So y equals the square root of 4 minus parentheses square root of x squared. So that just gives us y equals the square root of 4 minus x. And they just say x has to be greater than or equal to 0. But that one seems, I don't know, don't worry about that part. That one seems weird. Anyways, that's all you need to be able to do from this section. You really honestly don't need this for this class. You need this more for like Calc 2, sort of, kind of.
okay.
But they would teach you whatever you would need at that point, because you don't really do it like this when you get there either. In Calc 2, I didn't even do this kind of stuff, so yeah. This is quite possibly one of my least favorite sections of this whole book, because it's not
It's just kind of.
it's not even on the exam, I don't think, so
So you get it out of the way.
pretty much 5, 9, 13, and 19. So I've tried to give you like one that's pretty easy, a circle, an ellipse. I'm not saying they're in this order, but just in general. And then like one that requires a little more like thought, but still like pretty easy one. So More so that you can recognize if you're, like, based on what you're given, what kind of a shape, like, you're looking at, like, especially with, like, the circle and ellipse. Because typically if you're parameterizing something, it's because it's a circle or an ellipse, not usually the other. But